I'm just freaking recording the entire intro and the audio didn't work, so now I gotta redo it. I just don't think my microphone and iPad were compatible, but basically, standard deviation. So I'm gonna explain it because I was not going to, but I was like, it's kind of important to be able to conceptualize it. Standard deviation and mean absolute deviation are um essentially how the data and how so you have your average or your mean, as you know, and it's just how each of the data points varies from the mean. Because again, if the average is, if you're talking about heights of men in the United States, and the average is 5'8", but you have people that are 5'1", but people that are also 6'8", um, you can see it just helps to see and visualize the differences from the average, like, of the actual data points. So I'll, like, write it out. And really, there's this long, scary formula for it, but there's a much easier way to do it, which I'm about to show you. So like I said, just finding the deviation of the average. And so say you have the numbers 2, 5, 7, 9, and 11. First going to do is find the mean. So you just add them up and divide by 5. And the average in this case was 6.8. And so we're just trying to find on average what the difference between each of the numbers and the actual average was, if that makes sense. So in order to find the difference between each of the numbers and the average, you of course subtract the average to just see the distance or the difference between each of them. And so as you may tell, some of the numbers are negative. So if you subtract 2 minus 6.8, of course that's going to be negative, as you'll see in a second. And we can't have that because you can't have a negative distance between numbers. So 4.8 is the difference between 6.8 and 2. 1.8 is the difference between 6.8 and 5, and so on and so forth. You see they get positive towards the end, but there are still negative ones, and we cannot have that. So what are we going to do? We're going to square it. Quick side note that for something called mean absolute deviation, you just use the absolute value of the numbers, but for some reason, I'm not sure why, I'm not questioning it, but squaring it tends to have a more accurate result. So if you square it, of course, it'll give you a positive number. It's a large number, but don't worry, we'll take care of that later. We just need positive numbers in order to find an average. And then you're going to find the average of all of those numbers. And sorry, I made it look complicated here by putting them in weird orders, but I was just adding up all the differences together. And so then you'll add them up, divide by 5, but then to reduce the number, because as you can tell, we'd have a very large skewing number from the rest of the data. How do you get rid of a squared number? My recording's behind, sorry. But how you get rid of a squared number is by finding the square root of it. So first I'm solving for the average, which was 9.76, and square root of that is going to be in 3 point something, if I'm not mistaken. 3.12. And so what this is saying is that on average, each of the numbers is 3 away. Is either 3 greater or less than the average.